programming using Mastercam. So we want to do this. See how we can do thread turning in this component. So let's proceed. We have imported this part now in Mastercam. So my origin is here, but I want to put the origin this side. How do we put the origin on this side? There's so many ways we can create. So let me save the part first of all. I'm doing thread turning. So this is the part I want to do. This M30 by 2. So to do, let's go to model preparation, align to Z, and pick this face so it is aligned to our Z axis. We want to do milling. If we have a machine which can come through Z, we can align to this position. But I'm assuming that I have a machine which is upper left turret coming from x-axis and the upper side as it turns. That's why I'm aligning this axis to this center so that I can be doing my turn. So let's say this is my machine. It's a new office coding system. Then okay. If I say stop, say fit. This is a top, so front, right, isometric. So I have this plane. I've shifted from here to here. Let me check the plane. I want to ensure that this is the plane which is both for construction and for tolling. So this is the plane I'm going to use. The next, I want to create a level as the part I've imported. So get level number 2, then say this level. Set my turning profile. Can come to wireframe, turn profile, click on this, okay. Okay, so this is a party to be using because it has created my part. If I want to hide this, I want to hide a blank. Say this and selection. I want to hide my blank, hide the blank. Yes, selection. So it has hidden my 3D model. This is the blue line or blue wireframe is now, it was generated from my 3D. So then I hide it, selection, and hide, click on this and selection. So let's go to our machine now. Machine, we're doing turning, default, to parts. So I want to use simplest method as possible. Material I'm using aluminum. Using aluminum 7075. Okay, and then my stock is 105. I'm changing colors. I like using these colors. Use margin. OD is 96. The line is 182. This one I need to put a text stock on the left center. This 105 runs say 96 divided by 2 as my actual stock, which I'll also increase it. So 105 minus 96, it is 9. So I can put like 4, 42 millimeter for facing, and I'm assuming that I'm putting I'll put a live center. It is 212, so that's 40. Can preview, top, and minimize this. So this is what is my stock. Okay, come to chuck. So chuck here also, let me change the color. Let it chuck the color. I'm using parametric, but I can import a chuck and then I put here the jaws, the three jaw chuck. I'm just using normal one, which is already predetermined. But if you have all the specs, you can put a geometry here and say, am I using the inner one or outer one? It will automatically change. So using the outer one. Okay. Come here, I'm using the only left window, left window but upper turret. So I'm using the left window, upper turret. Okay. Next, I want to do facing. So we go to facing. From facing, I'm using that tool. You can say this is my OD facing. Facing reference. Can put here 100. Put here 100. Okay. It is 2000. My machine is 2000. Check finish. That is okay. 1200. It is 900. It will cancel. Don't worry. I'll tell you next the formula on how to calculate it. This parameter and check here with 1. This 23. Filter after 0.02. It's my finish. Case of any corner to inspection. Check. Okay. Next, I can go to turning. Turning, you can expand here. It is here. It goes change direction. Goes next. I can pick even the last one. There's another way of picking it. Just say go next, go next. So that's where average. Okay. Then this is my OD rough. Use capital letters. OD rough. Check here. 100. Both sides. Okay. Using the same tool. 2000. This is 1200. Okay, equivalent is checked. So let's go to this. I want to extend this one by 5 for this by 6. So it's now I am doing that. 0.002. My filter is outer boundary. So this validated be 0.1. 0.1. Okay. So I'll show you how to create the tool to create to the next session. So you can click this. Then next you can do finish. Pick the last one. Okay. Finish tool. I'm using this finish tool. This finish tool. OD finish. So check here. 100. 100. It's 2000. 1800 maximum. 0.1. 0.1. Okay. Finish parameters. So laid out by 6. Okay. Filter 0.002. Okay. So I don't need to put 0.00. Check. Next, I want to do here threading. So let me hide these toolpaths so that it doesn't confuse me. Programming. Next, I'm doing threading. So where is the thread? The thread is here. Yes. So I'm using the light one. This is the thread. Let me check the tool itself. So this is the tool I'm going to use. The OD, if you're using internal, it should be this. I'm using the outside, it's outside threading. Hide this internal threading, so I'm using outside. My size is okay. I'm going to use a default pitch. Pitch should be 2. Yes. Here, my A is 16. I'm using 16. C here should be 4. Should be 2. Check here. Let's go to this and it's okay. That won't give me a good thread. So it's not too much here. I'll use my default one. I'll explain why I've done that. So the OD, you say OD thread reference coming out from, I think even 100 is near. Yeah, it's okay. So my piece 96 also, so okay. Thread this one from a table. I'm using metric. Measure diameter is 30. I'm waiting 30 pitch. So it is 30. Define one. 30 by 2. That's okay. So to calculate here the pitch, also calculate. So it takes 30 minus 2, which should be 28, but because it has allowance, let me check the allowance without using the fine, because it's made to fine pitch of 2. The pitch of 2 is, so it calculates these parameters. That's the beauty of Mastercam. You can do this again. I can show you even I can do a draw. I want to do a draw. Yeah, so the angle is okay. I'm using my metric. Where is starting? You can start from here. Where is it ending? It can end with this point. Yeah, it's okay. OD. OD not face threading. Hitting okay. I'll go to cut parameters by default. I want to leave this one as my default. Okay. Then I can select all of them and do now simulation. See what will happen when you do more simulations. To see what will happen if you do simulations. Expand this. My computer is hanging. To buy a powerful computer. Put it isometric. This is too big. Yes. I want to rotate it this side. So I'm using the upper turret. It's on the upper side, upper left turret. Expand this. Expand it so you can see. Then I want to record this one for the sake of documentation. Facing, it's turning, half turning, and finishing and then doing thread. So what's the thread? The threading. Yes, good. It's okay. You can generate a G code, select all of them, click G1, then okay. Thread. Just calculate, then generate the G code. I'll show you the G code. Now how to also edit the G code in the program. You can edit the G code. So I want to remove even this. So this. Using a machine which requires cement, you can put G291 for basically this is for Siemens 802, 808, 808 and even 810D. Utilizing that, you can put SinuTrain here so that the machine doesn't read this. Also put G70, but this one I want to put it to jumbo. I put semicolon, it jumps. Same to this, it will not read this. So remove this. If you're using cement with D1, so let me put semicolon at the back so that it doesn't read this. And go down the second or the half turning, and then it goes all the way down. It comes here. Can remove this too. Then this one can also remove this. Second tool. Second operations, third operation for finishing. Can move this 0. You can use M06. M06. In the case, let me use D2D1, semicolon at the back, the safety. I'll show you how to put the safety here. So safety G, G40, G00, G20, G95, G54. Using G54 like that. So that's how you can write program. I say G64 again, make it fine. Doing cornering, can go all the way. Remove this tool, this one. Can also check this. Put semicolon at the back so that the machine can jump. So the same to this, semicolon, same to this, semicolon. Then you can change here. We are using T3 D1. The back can put a semicolon. The purpose of changing the tool automatically, depending on how you are initiating it. You have to it now. Go home. It's okay. This is a program. So when you look at this program, first one, tool 1, we're doing facing, second is already having the same tool, it comes to finish. Finish starts from here. Second tool, so even telling the tool you're going to use, tool is here, we are going to use, and then expand it to well. And start from the first one, expand it, I'll explain why it means. So this one you're using a Siemens language or Siemens controller, which is 802, 808, and 810D. Use G291, but to say well, because it will be ISO direct. Those people use normally like using ISO language. My material is aluminium. Then I'm setting my tools number 1, option number 1. Body half using a tool of angle 80, insert CMMG 120408. It's also giving the insert code. Then that's operation is OD facing, that's outside diameter facing. That is the code of the program, how it looks like. 18G, I'm using G18 because of XZ plane. Cancel any two compositions, use 00 for rapid movement. Then using absolute programming, using ensure that it's exact or fine stopping, doing cornering, then using filtrate of millimeter per revolution, then you go to work offset of 54, you go to cancel any constant spindle speed using 900, yeah, clockwise, and then it goes as it moves. From here, it's doing now, this is now what you call facing. So this here is doing all the facing, here it comes to all the rough, goes all the way is the filtrates, and it finishes, it comes to all the finish. It's finishing using the same second tool, which is VNMG 160408 at angle of 35. That's tool number 2, option number 2. In Siemens, you can use this Siemens, but normal machines has Fanuc, GSK, you can use this code, the tool, that's the code for finishing. Then it comes thread. So if your machine doesn't accept the scan cycle for G76, you can use G82 like HNC. You can use Angel Star, you can use G82. Needs to put a semicolon. You can use G82, but syntax will change. Or you can also use G32, you can use G33, you can use G78, depending on the context and the format of the program. So your machine will determine which code are you going to use for this. But if you're using Siemens, in most cases it can become a cycle. So make sure you're using cycle. It can be cycle 95 or 82. It should be 82 if you're using Siemens. So ensure you check the correct contour for threading. But this is the simplified version for most of the house, Angel Star, even GSK, you can apply this. Good. So this is what I wanted to show you today, how to program turning, then you do a thread, then you understand which kind of G-code you're going to use. And from there, you can generate a G-code, edit. This is how to edit G-code. By now, it's saying you this color, what? This is yellow. So if you save, like, let's say Control S, changes to green, showing you where you have made a change. Where you see any this line, it means you have made a change. This one is not important. You can check it depending on the machine. So if you see if you make any change, it changes to yellow. If you control save, it changes to green. So this is now how you can update your program. I can now save. Using Siemens. Let me use come to documents. Let me use what I like most about program. I can say .mpf Siemens. Yes, and then I want to load this program. in my machine. So let me open this SinuTrain. I don't know if it will take a lot of time, but let me open it and then we load the scene. What it tell us where to change so that we can change the program. I'm using this 840D, so I want to test with 840D. So let me use this DMG mode, CTX 840D, using the CMN 840D. Let me click start the machine. I want to load the program to see, or I can just copy. I think I have the program. Yes, yeah, I have the program. Let's copy the program, paste it there, and then do a simulation. We'll see where how it will behave. Let it start. Then I'll show you how to start the machine. Now this is the controller for Siemens controllers. It's a CNC simulator called Sinomeric SinuTrain. So I want to show you how to load it, and then also you can be able to see if those G codes will be able to run on the machine or not. It will be giving you alarm because you remember this is an advanced controller. So how do you ensure that it runs? Let me go to the program first, copy this program. Where is this program? It's here. Control all, the program. I want to copy the program first. Control all, copy. Then we come to this SinuTrain. First of all, because it is a new controller, most cases I think it is normally it is the 840D. So you make sure you check on these ones. This is the one we are going to use. Let me home the machine first. Home the machine is ready. Okay, I think confirm if it's home there. And the y-axis, the fourth axis, the fifth axis, the seventh axis. If you want please call the system, then remove this button for home. Come to machine. It's okay. TSM okay. So program manager. Then let me go to this say new program. Let's say I'm not using Shopton, but let me say test2. Enter. Maybe open. No, I don't want to use the Shopton. I think I've just let me go to this program manager. Not use this Shopton. New. Let me change this. I want Shopton. Let me use this program. Guide. Is it giving me this program? I want to go to this program manager. Let me open any program. I want to use this kind of shortcut first. I want to use the shortcut. Let me use expand this and this. I want to change all here, all of them. Cut. Paste this. I want to test this. It will give me whatever I want. Then here, let me put my stock so I can come to variable blank. Then here, the largest diameter, largest outer diameter of set 105, 0, so it's minus 212. Then it's climbing at -20, so it's 176. Okay, then accept. So that's my stock. Also, the tools they have put, so ensure that like this CNMG is it the same tool that we put in the tools. So come to offset, check your tools. Are they here or not? Maybe I can create a new tool here. Let me create a new tool. There. I could want to duplicate it. See, this is CNMG 0408. I want to create a new tool. To create a new tool from listing here. So from magazine to let me change. Should I change this now? Before I change this, let me check the name which is preferably correct. Second tool is okay because it's for finishing, but the first tool we can't use this one unless we also program it from the other side. So I can change this, or I can take this tool. It will affect my output. Change the tool from this side. Let me say new tool. I'm using roughing tool from this here. from this. Okay, then you can say the tool is CMMG 120408. The angle is 80. Enter. So the angle is 80. 80. Correct. This is 12. Enter. Right. Radius is 0.80. Enter. 0.8. That's okay. So it's tool number 14. So I'll go to program. Then I'll pick a tool. This tool, I want to change this tool. I say I want to pick this tool, do editing, program. I want to pick a tool. So this one is T14 D1. So that's the tool I'm going to use. So here, let me put a semicolon so it doesn't write that. So that's the second tool I'm going to use. I want to test that. So let me test this before we change all the tools. Then we see it's okay. You can say do a simulation. It will give you an alarm where the code doesn't match. Then see how to rectify it. Now you see this one is telling you there's a block which is block G99, which is not readable. So how do you edit it? So it's right here. Come to this one, you can remove. You can say using G95. Then you have this. Check where it will give you the error. So this is the beauty of this one is to give you error is like say block 931, the error is syntax to text. So edit, it goes there. So you see this one has a problem because I just copied it from the other side, so it will give me where the error is. This CNC simulator is good for you to remove all the errors when you're doing simulation. Yes, until you get the correct one. Also, I've not set. Now you see this one is it has done I've done Mastercam programming. I have imported my part in SinuTrain, that is numeric SinuTrain. I've done my programming. Then it has done even the threading. But you see, remember here, telling you that the block 177 is illegal 202. So when you click edit, it goes you to this. So you can remove this. The tool that is a tool for finishing, yes. Then you can go and also check again until it's okay, because this is I'm using a new controller, so it will be telling you where the problem is. And now also telling you this block 177 still tool number is illegal. Why? Tool number. So you can come here, tool number. Why? Because Siemens doesn't read this. That's why I told you that if you're using Siemens, make sure that you use T and D. So this one is okay, but not T0202. So you can continue. Press simulation so that you can see what will be giving you until you rectify the problems. Once finished telling you block 182 G50 is unknown, so it is telling you where to edit. Why? G50 is to select the corner system, the workpiece corner system. So there's no need of you can use G3 if it accepts or not. So that's how you can do a simulation. Troubleshooting your program. This is what we call troubleshooting your program, editing and removing all the errors until the program is okay, depending on the machine, because machines are different. And then it's all telling you block 214 is illegal. Why? 214. You can look at this illegal. Why? It is illegal because the tool is not right. This tool is not right. Which tool is for threading? Check from your offsets tool list. Which tool is for threading? You can check the threading tool. Do we have a threading tool? Yes or no? So threading tool is number 8. So you need to check the threading tool and on the pitch. The pitch also is important, so you can check the tool is number 8. So come to your program, then write here T8 D1 so that you can remove this. Yes, and then also ensure okay, let me run again so that you can see how to troubleshoot your program when you load to a new controller, which maybe has an advanced way of programming. Block G220 G76, and that's why I told you Like when you're doing this threading, it may tell you where the problem is. You can change to G78. Can you check if it accepts? Because there's a new controller and there's the ISO. There is an ISO dialect to program, which may not necessarily be compatible with Siemens. Even this one doesn't be compatible. So this one is a way of writing a program. So I will show you how to write this program. You can use it for this one code to accept. You can start from here. Let me show you simplest. You can use G32. From G32, you want it to go to a depth of, let's say it is 30. So 30 minus 0.8, so we are getting 20, that is x29, 20. So before that one, they put x29, 29.4, enter G32, then G32, Z, let me put Z minus 20, enter G00, x34, Z2, then go to x28. Remember, it should go to 20, it should go to 27.4. So I can say 28, or let me remove one by 1. That is 29. I have a reason why. I'll tell you the reason why. From here, G32, Z is minus 20. Go to G00, x34, Z2, then go to x27.4. I'll explain to you this is a thread. Go to G28, that is G32, Z minus 20, then go to Z minus 20, go to, let's go out, minus 20, G00, x34, Z2. This is how you going to program this. So this is 27. Then we reach here. I'll put here semicolon because I don't want to change that. I'll explain to you what it means. So run again. You see if it accepts G32 or not. This is how to edit the program and see where the problem is. It's telling you N1 G32 unknown. Yes, it's one N1 G32 unknown. Why? You can use G33. Check from your machine. So this is what we call troubleshooting. You need to check a machine which code does accept for threading. Because I'm using ISO, but if you're using Siemens, actually things will be very fine. So don't worry that. And then the controller is new, which is 84D from which the one I was using, which is 8, which was 808D. So this one, the syntax, yes. So you can also change this syntax. It will affect them because you have put it from this one, the rest were not put. It can affect. So you can use this syntax. There is this numbering actually. You can remove this numbering. There's that do assimilation again. Assimilation again. Up to 21. You can go to edit. Up to 21. Why? Does it accept G32 or 3? So you need to know which code your machine will be accepting for threading. So that's why when you program using Mastercam, you need to know the machine you're working with to make it easy for it to work on your machine. So this is what you call troubleshooting of your G code. So I will proceed in the next session to show you how to put the correct G code for the threading using the Siemens language. So this is what we are programming in Mastercam. And then we have moved our program in our Siemens SinuTrain simulator to see how it works. Thank you.